7.4 is not new. 7.4 is only taken 7.1, 7.2, and 7.3, put it together and ask you to determine which one are you using. So let's take a look at this item here, which is, let's say that on your test, right? On your test, if you were to take the test in class, you on the same page, you might see this 3 items. But for you guys, the test is online, you probably see 1 question at a time. But look at this thing here. Let's say if this 3 questions appear, how do we determine, is it the proportion, one pop z interval, or is it the t interval, or is it the z interval, right? So if you look at this thing here, number 1, they ask you a simple random sampler of 400 voter, 220 say that they were planning to vote for the next election. Construct a 99% confidence interval for a proportion. So if you look at this thing here, we can see that looking at this item here, this word tell you that we are in 7.3, because that's what we've been doing, which is we construct a confidence interval for the proportion. So everybody see that construct confidence interval for proportion, that's one prop z interval. That's what we did before, right? And if you read number 2 and number 3, everything is exactly identical. And what do they ask us? Which is they ask us to construct the confidence interval for the population mean. And both of them ask you the same thing go. Both of them ask you for the construct the confidence interval for the proportion mean, population mean. So how do we determine, are we using the t interval or are we using the z interval? So this is what you have to looking for, ladies and gentlemen. You have to looking for in your problem, do they give you the population standard deviation? Or do they give you the sigma? Reminder, this sigma is the population standard deviation. So if they spell it out, if they say the population standard deviation, if they give you the population standard deviation, this is 7.1, which is, this is your z distribution, this is your z interval. If you look at number 2, they only say standard deviation. And again, like I mentioned yesterday, when they say just standard deviation, 99% or 95% of the time, this standard deviation is the sample standard deviation. Or in this case, the S stands for sample standard deviation. And if we deal with a sample standard deviation, we are in 7.2, we are in the t distribution, and we have to use the t interval. And that is the key for this problem, is you have to ask yourself, do they give me the population standard deviation in 3? If they do, I use the z confidence interval. If they don't give me the population standard deviation, I have to use the t, okay? So let's take a look at this thing here. Let's take a look at 1, 2, 3, 1 by at a time. So looking at this item for number 1, which is, we know number 1, we have to find the population proportion, which is population proportion is easy to find, which is just standalone section, right? Which is, as long as you see the word proportion, you know they're in 7.3. And how do we find a confidence interval for a proportion? Well, we need an n, right? We need an n, which is again the 400, and then we need the x, which is the 220, and then we need the confidence level, which is in this case 99%, which is your 0.99. Okay. Again, the reason why I type proportional is because the direction says state which type of parameter we estimate, right? So again, we estimate a proportion, and there's nothing there to it, right? So looking at this thing here, once you have this thing here, hopefully you remember that we're using the feature on your calculator, 1 prop z interval. And if you type in the 1 prop z interval, the x, the n, and the confidence level, you should get this confidence level, which is 0.48486 and then 0.614. And like I mentioned to you guys, make sure that whenever you calculate the proportion, is in terms of the decimal, is point number, right? So question with this number one. Number two and number three, like I mentioned, the parameter that we are trying to estimate is the mean, which is they tell you to estimate our confidence interval for population mean. So once you have this thing here, which is again for population mean, like I mentioned, you have to ask yourself this question. This is the biggest obstacle, or the biggest thing that you have to ask yourself is, are we dealing with the sample standard deviation, or are we dealing with a population standard deviation? And when we get to chapter 8, it's the same question. Are we dealt with a sample, or we dealt with a population standard deviation? So with this thing here, we deal with this S, right? With this S here, this notation, we are working with a sample standard deviation. And if we work with a sample standard deviation, we are dealing with a T distribution. And if we deal with a T distribution, we have to use the T interval. And to do the T interval, this is the fourth thing we need. Well, to do the Z interval, you need this 4 item too. But again, you need an N, which is the N is the psi, which is 18. We need the X bar, which is again the point estimator, which is 71.32. We need the S, which is 15.78. And then the confidence level is 95, right? So again, looking at this thing here, if you type in the T interval, if you go and you do that stat test T interval, this is what you should get, which is point, again, sorry, it's not point, it should be 63.47 and 79.17. Okay, it's not point. Make sure on the homework, on the Connect map, don't put 0.63, because if you put 0.63, 0.74, it will be wrong. Okay, so again, I copy and paste and I forgot to delete that decimal. Question with C, question of why we using the T interval, or we deal with the T distribution here. All right. And again, if you look at this thing here, which is I mentioned that we're dealing with this item, and again, the key concept is we are dealing with population standard deviation. And again, if they don't spell it out, they might give you this notation, which is the sigma. So they either spelled out population standard deviation, or they give you the sigma, and that should be a keyword to use the Z distribution. And if you use a Z distribution, which is we still need the N, we still need the X bar, we still need the standard deviation, and then we still need the confidence level. It's just that now you tell your calculator that using the Z interval and not the T interval. Okay, so looking at this thing here, looking at this item here, question on how to distinguish the difference between the Z interval versus the T interval. Because again, that's our goal for today. Our goal for today is hopefully when you look at the problem, you can distinguish the difference between the T interval versus the Z interval, or how to different the problem relate to the Z versus relate to the T. And again, if you type in your calculator, you should have this, which is 2.45 and 4.29. Okay, so that's your confidence interval. Again, anybody does not have the answer I have on the screen here. So all of you have the answer. All right, so question on how do we determine if it's a population, well, how do we determine if it's a Z interval versus the T interval? All right, so looking at this thing here, let's take a look at the next set of problem, which is again, same thing go, right? Number 4, 5, and 6, they ask you the same thing, which is identify which parameter we are estimating, and which one should we use? Should we use the Z or should we use the T? Okay, so looking at this item here, and again, hopefully you guys see that number 4 clearly there's no problem now, which is if you read this thing here and they ask you to construct the confidence interval for the proportion, which is proportion, we know there's nothing in a proportion, right? It's just we use the one prop z interval. So looking at this thing here, which is again, for proportion, we know that we need the n, which is what is the total number of people that we have, which is 250. What is the x that we have, which is 185. And then again, from there, what is our confidence level, which is in this case, the confidence level is 0.95. And again, you will see that they will ask you a lot about 0.95. But looking at this thing here, if you use your calculator and you use this one prop z interval, you should get this interval, which is 0.686 and 0.794. Question with this thing here. Now, if you look at number 5, if you don't have question with a proportion problem, and hopefully you won't have a question with a proportion problem, because that's the only feature we're using for proportion is one proportional z interval, which is one prop, okay? So let's take a look at number 5, sleeping time. In a sample of 87 young adults, the average time per day sleeping in bed were 7.6 hours. Assume the population. Again, looking at this thing here, hopefully you guys are happy because you see this thing here. You see that assume that the population standard deviation, meaning they give us the population standard deviation. And if they give us the population standard deviation, they spell it out for us. We know that anything related to population standard deviation, then given the population standard deviation, we have to use the z interval or the z distribution. Everybody see that. Again, the goal for today, the objective for today is if you read a problem, you have to know which formula or which item that we're dealing with. Or we deal with a z or we deal with a t. If you live in the lecture today without knowing how to determine is it the z or the t, then this day I have failed you, okay? So make sure that you know what to looking for so that you know that we're using the z distribution or the t distribution. And again, looking at this thing here, they spell it out. So we know that we have a population standard deviation. Therefore, we're using the z distribution, which is we need the n, which is 87. We need the x bar, which is the 7.06, which is the mean. And then we need the standard deviation, which is the population standard deviation, 1.11. And then we need a confidence level. And then this is our feature that we tell our calculator to calculate, which is the z interval. And if you type it in, all the number I have, you should get the confidence interval of 6.75, 7.37. Question with number 5, why I use the z interval? Anybody does not have this answer? And again, sometimes check my answer can be wrong. But anyway, if you don't have question for number 5, let's take a look at number 6. High octane, right? 50 measurements are taken of the octane rating for the particular type of gasoline. The sample mean rate in percent were 85.6. With the standard deviation, what does it mean with the standard deviation? Well, first of all, I mentioned to you guys, if they don't spell it out, the population standard deviation, if they write it like this, most of the time, 99% of the time, this is your sample standard deviation. And again, if you look at this thing here, they say the sample mean is this with the standard deviation, meaning this standard deviation is belong to this sample, right? So again, because they say with the standard deviation, this thing here, this is your sample standard deviation. The keyword is sample standard deviation, because if it's the sample standard deviation, we have to use the t distribution. And again, the T distribution or the Z distribution, we still need this 4 item. We still need the N, we still need the X bar, we still need standard deviation, and we still need a confidence level. It's just that when you input, when you tell your calculator, you have to ask them or calculate the Z interval or calculate the T interval, okay? So again, that's the only thing. If you can identify the T versus the Z, you have chapter 7 down pat. And then chapter 8 will be very easy too, because that's the main objective, is to determine, are we using the T versus the Z? And again, you know, your calculator do all of that tedious calculation for you. So the calculation aspect of this class is not hard. The hardest part of this class, like I mentioned, as always, is to determine what information they give us and what information do we need to calculate, right? And again, tell the calculator to calculate for you. So again, question with this 3 or 4 problem or 6 problem, we have question on how to determine the T interval versus the Z interval, and how to use your calculator, utilize your calculator to calculate the answer for you. All right, if you don't have questions, let's take a look at one more problem. I have a few students send me this question here. So again, I just took this question from the book, but I think it's very similar to the question on your homework. And again, yesterday I told you that today I want to show you this question. So first of all, let's take a look at what data they have, what kind of backstory they're giving us. So the cost of repair, a sample of 8 repair record for a certain fiber optic component were drawn, and the cost of each repair in dollar were recorded with the following result: $30, $35, $19, $23, $27, $22, $26, and $16. So this is the individual cost for the repair, right? Now they ask you construct the dot plot for this data, or the assumption for the construction of for constructing a confidence interval for this mean satisfy. So we know that they asked us to construct the confidence interval for the mean, right? So let's take a look at the dot plot first, which is reminder in chapter 3 chapter 3. How do we do the dot plot? Well, the dot plot is basically, we have our number line, right? For me, I go by 5, which is 15, 20, 25, 30, 35. And all I do is I go in and I ask myself, what data do I have? Which is, again, the first data is 30. I go to the 30, I put a dot, right? The second data is 35. I go to 35, I put a dot. And 19, I go to 19, I put a dot. 23, I go to 23, put a dot. 27, 22, 26, and 16, right? So again, I have 8 dot here that represent the 8 data that I have, right? So again, looking at this thing here, is it okay to assume that this item is normally distributed, right? If you remember in chapter 6, if we collect a lot of data, this is the assumption. If we collect, if our 8 data is normal, right? Or if we can use this to approximate the normal, then eventually if we have more and more data, all of this thing here will become a normal, right? If it's 8, if we collect like 1,000 or 1,000,000 data, then this data will become a normal distributed if this 8 item fit that description. So what is the description that we're looking for? Well, first of all, there's no outlier, right? We have to see if there's an outlier, which is, again, there is no outlier here. And there's no skewness, right? Meaning they don't have like a bunch of data on the left side or the bunch of data on the right side and then less, right? So, and the other thing is we don't have multiple, which is we don't have any mode, right? This thing here is kind of scattered, but we don't have any evidence that we have a multiple mode. So none of these 3 items happen, then we say, yes, we can use this data to assume that this data is approximately normal, because they don't fit the three description, the outlier, the skewness, and the mode, okay? So now, if you look at this problem here, if you look at this problem, again, part A on the homework, I think they only ask you to construct the dot plot, which is you go to each number and put a dot. Now, if you take a look at part B, they ask you to construct the confidence interval for the mean. So if you remember the previous two slides, I asked you, if they ask you to construct the confidence interval for the mean, we need a few things, or one thing we need to know is, the most important thing we need to know is, do they give us the population standard deviation? If you look at the screen that I have right now, if you look at this problem, do we see any population standard deviation anywhere mentioned? We don't, right? And as you can see, they don't give us any sigma, right? So on the homework, I think if they give you the sigma, if they give you the simple, then we don't deal with population. But looking at this problem here, they don't give us any population standard deviation. So we know that if they don't give us any population standard deviation, we need to use the t distribution. Okay, meaning again, if we're using the t distribution, meaning now the only thing I can have is I can find the sample deviation, the sample standard deviation. How, you might ask, right? How do we find the standard deviation? Well, we go back to chapter 3, right? And again, this is because I don't have the population, I need to use the t distribution, and reminder to find the t distribution, we need this 4 item. And if you look at this thing here, you say, well, Mr. Tran, I don't have the point estimator, which is you don't have the mean. But we can find the mean, right? How do we find the mean? You just add all this thing up and divide by 8. And that will be your mean, right? We don't have the standard deviation. We don't have a sample standard deviation, but we can find it, right? How, which is reminder, we do the 1 for stat. So let's take a look at this thing here. Let me share you the screen. So the reason why I give you this thing here is I want to point out that given this item here, we can find the mean and the standard deviation by go back to chapter 3. We need to edit our data in L1. So to do this thing here, reminder, you hit stat and then you choose edit and then you press enter, which is again your L1. So all I'm doing is I type in 30 in L1, 35, 19, 23, 27, 22, 26, 16, and those are my 8 data. So if you remember, you type your data in L1, and then what do? We hit stat, and then we do the calculate, which is the 1 for stat. Hey, it's still there, right? Once you learn it, it's still there. You still have to use it. And again, if you do the 1 for stat, you see that we have the X bar, which is the 24.75, which is, that is your mean, that is your point estimator. And then we have the S, which is the S is 6.088631092, which is, again, everybody see that in order for us to use the t distribution or the t interval, we need the X bar and we need the S, which is, again, the X bar, we can find the X bar, which is the mean. The S, we can do it, which is the 1 for stat, which is, again, all I did was I typed my data, which is they give you the raw data. They give you the raw data and they tell you, well, given this raw data, we don't know what the population standard deviation is. Give me the raw data. Can you find me the confidence interval? Which is, again, you have to manually find the X bar and manually find the standard deviation. If not, this is where the other thing come in. If you don't want to find your mean and you don't want to find your standard deviation, if you go over and again, since you verify, again, the first thing is you have to verify, do we use the Z or the T, which is in this case, we use the T. So since we verify that we use the T, everybody see that if we use the t-interval, we hit stat, go to test, t-interval. Now, instead of go over to stat, you have to choose data. The data here is basically, you see the data is blinking. That is what you want to do, is you want to choose the data, which is, again, the data have to be highlighted. You just tell your calculator is, go ahead, I have the raw data in L1. Go ahead and use that raw data and calculate for me the 98% confident. Your frequency, leave it 1, don't change it, don't do anything, which is the list is your data, which is I put my raw data in L1. I tell my calculator my data is L1, go in L1, take those data and calculate for me the 98%, which is 0.98, which is if you press this thing here, this is your output. And again, ladies and gentlemen, remember I told you guys that the mean 24.75, that's what your mean was. And I told you that the standard deviation 6.088631092, that is your standard deviation, which is, again, those are the two things we have. If you have those, then you don't need to use the data. The only reason why we choose the data is because we have the raw data. And if we have the raw data, we input the raw data in L1 and we tell the calculator, go to L1, take that data and calculate to me the confidence interval, which is, everybody see that the confidence interval that we have is 18.3 and 31.2. Okay, and again, that's what we have here. If you look at this thing here, we use the t-interval, which is, again, we using the data feature because we have the raw data. We use the data feature and not the stat feature. Okay, the stat feature is when you have this 4 item. But if you don't have this 4 item and you have just the raw data, and then you do the raw data by using the data feature, which is, again, this is your answer. So question, first of all, question on how I have this interval. Question on how I have the answer here. Any question at all?
I used the stat versus data, and it still came up as the same answer.
Exactly. I mean, if you have the mean and the standard deviation, you should get the same answer.
Okay.
It's just, so that's why I show you that if you do the 1 var stat, if you do the 1 var stat, which is the 1 var stat give you the mean, which is x var, and the standard deviation, if you use that information into the stat, that's fine. It should give you the same answer.
So using the data option means we can skip the 1 var stats, just put the data in L1 and then go straight to the t-interval with data?
Exactly. Okay. That's it. That's it. We use the data only when we have a raw data. When we have a raw data and they tell us that they don't tell us anything in terms of the population standard deviation, or they don't mention anything in terms of that, then we use the data feature. The only reason we use the stat feature is we got the data already. That's why we don't use the data, we use the stat feature, okay? So question with this particular item here, question with how, you know, like I say, the main thing for today is hopefully you guys have an idea, or you guys know how to determine when you use the Z interval versus when you use the T interval. And again, I want to remind you guys, right? I want to remind you guys that this is the only 4 item we have, not 4 item. This is the only 3 feature that we're using. The 1 prop Z interval, the Z interval, and the T interval. Those are the only 4 feature under the test that we're using now, okay? Because we're looking for the interval. And again, the other one is the sample size, which is you just plug in the number into the formula and then tell your calculator to calculate it, okay? So question here, and again, hopefully you guys have a better idea of how to determine the Z versus the T. All right, if you don't have question, ladies and gentlemen, this is the end of today's lecture. Again, This is all I have for you guys today, which is determine the difference. And that's what 7.4 is, which is determine the difference between the Z versus the T, and how to use the data item rather than just using the stat item all the time. So if you don't have question for me, be safe out there. And